Hello, Algebra 2 small group. I am sending out this review. This is 7.09 Unit 7 review because I'm out of the office on Monday, April the 8th, and I wanted to send you this Unit 7 review so you would have it to be able to use. Okay. We'll look at this week's announcements. We've got section 802, 803, 804, 805, and then on Friday we have a catch-up day. At the top of the announcements, please remember if you're a 9th grader, a 10th grader, or 11th grader, that sometime soon in the next 2 to 3 weeks, you're probably going to be getting an email, or you'll see it scheduled in your OHS, where you're going to have to take your EOY, your end of year testing. That's the STAR 360 math and reading. That's mandatory. That is virtual testing. You don't have to show up. That's what we do 3 times a year. We set up a neuro session for that. So please be looking for that. And graduation, congratulations to you seniors that are getting closer and closer and closer to graduation, which is May the 16th. A couple reminders: if you're seniors, your TGAs are going to close on April the 30th, and your CGAs are going to close on May the 2nd. If you are not a 10th grader, so that means if you're a 9th grader, a 10th grader, or an 11th grader, your TGAs are going to close on May the 13th, and your CGAs are going to close on May the 15th. So I'm going to repeat that. Seniors, TGAs close on April the 30th. CGAs close on May the 2nd. 9th, 10th, and 11th graders, TGAs close on 9th, 10th, and 11th graders, TGAs close on May the 13th. CGAs close on May the 15th. So they'll be coming up here close. This year will be over before we know it. On this first slide, I've got some definitions and some formulas. So let's talk real quickly about the definition of point estimate. The definition says when a sample statistic is used to estimate the population parameter. And then I like to say, just it's a little bit more, it's simpler, it's the midpoint of the interval. So, if they give you an interval from I'm going to make it easy for myself. So like 1 to 3, then the point estimate would be 2. Then the point estimate would be halfway between those two. All right. If you're finding the point estimate, we have a pretty basic formula where you add your min and your max of your interval. So you add your min and your max and you divide by 2. So if we added 1 plus 3, we would get 4. We divided by 2. That's how we get 2. We can see 2 is exactly in the middle between 1 and 3. But usually your min and your max are not as simple as the numbers 1 and 3. When you're doing margin of error, it's plus or minus, and then we're going to subtract. The max always comes first because it's larger. We always want the larger number to come first when we're subtracting. A lot of people forget that plus and minus, and then we would divide by 2. So margin of error plus and minus, max minus min, divided by 2. If the directions say find the margin of error with standard deviation, you cannot use the max minus min divided by 2 formula. You have to use the max minus min divided by 6 times 2 formula, and then the plus and the minus. We'll look at a couple examples where you're using, we'll go over which formula to choose. Let's take a look at number 1. The question is right here. I know this is a little bit small, but it says for their next musical, only 10 members were asked how many hours of sleep they got the night before. Their responses are recorded in the table. So this is all the members, and this is just a sample. So the question is, what is the sample mean? And we know that mean is average. And you just have to know not to use this big group up here. We're just looking at the sample. So we'll add all of these numbers. There are 2, 4, 6, 8, 10 of those numbers. We'll add them up. We'll divide by 10, and that's going to give us 8.4. Okay, so we're going to find the average of the sample. That's how you would do number 1. Number 2 says, suppose 10% of all redeemed coupons at a supermarket are 50% off of the item purchased. So if we had some coupons for a grocery store, only 10% of them, 50% off is a really, really good deal. So they're not going to give you a lot of 50% off coupons. They're only going to give you 10% of the coupons. That'll be 50% off. It says a simulation is used to model a coupon randomly selected and then recorded as 50% off or not 50% off. Which simulation best models the scenario? This one is really focused on the fact that it's telling you only 10% are 50% off. So this says if 50 coupons, the same size, are put in a hat, of the 50, 10 read 50%. Well, if you do 50 times 10% and 0.10 is the decimal for 10%, you're going to get 5, not 10. The next one says if 80 equal size pieces of paper are put in a hat and of the 80, 10 read 50% off. Again, if you take 80 and you do 10% of 80, you're going to get 8, not 10. The third answer says if 40 pieces of paper are put in a hat, 4 are going to read 50%. So if you do 40, if 40 are put in a hat and you do 10%, so that means you multiply by 0.10, you are going to get 4 are going to read 50% off and the rest are going to read not. So it's going to be this one. If you looked at this one, there's 30 and 6 are going to read 50%. 10% of 30 is 3, so 6 is not going to work. So we're going to choose that third answer. Number 3 says a drawer contains black socks and white socks. 40% of the socks are black socks. A number generator simulates randomly selecting 10 socks from the drawer. The number generator is used 10 times, and the number of black socks in each trial is shown in the dot plot. So 1 time, 2 black socks were pulled out of the drawer. 2 times, 3 black socks were pulled out of the drawer. 4 times, 4 black socks were pulled out of the drawer. And 3 times, 5 black socks were pulled out of the drawer. So it says which description is correct based on the generator. So if we pulled out 10 socks, it says 40% of them should be black. So if I take 10 and I multiply it times the decimal for 40%, I get 4 black socks. So what should happen is most of the time, according to the percentage here, we should be getting 4 black socks. So once 2 black socks were pulled out, twice 3 black socks were pulled out, 4 times 4 black socks were pulled out, and 3 times 5 black socks were pulled out. So we're wanting everything to be centered around 4. So if you take a look at this data, most of the dots are 4. A few are to the left, 3 are to the left, and 3 are to the right, but they're close to 4. They're not 0 and 10. They're not spread out like that. So this says the number generator is not fair. I'm going to disagree with that. This one says not fair. These two say fair. So it's going to be one of these last two because most of my data is centered around 4, which would mean 4 black socks. So this one says the number generator is fair. It picked the approximate percentage of black socks most of the time. The last one says the number generator is fair. It picked black socks half of the time. It's not supposed to pick it half the time. It's only supposed to pick it 40%. Half would be 50. So they're trying to throw you off there with a half the time. So it is true that the number generator is fair, and it picked approximately 40%, okay, which was 4 black socks most of the time. All right, let's take a look at number 4. A number generator was used to simulate the percentage of people in the town who can skateboard. The process simulates randomly selecting 100 people from the town and was repeated 20 times. The percentage of people who can skateboard in the town is shown in the dot plot. which statement is true about the population. So if we just look at the dot plot, this is 15. So let's see what the question was again. The percentage of people. So this is 15% of the people could skateboard. This is 20% of the people could skateboard. This is 25%. This is 30%. And this is 35%. So it says most likely 10 to 20% of the town can skateboard. So we're looking for where the most of this data lies, where the most of the points lie. So if we go to 10 to 20, most of the points are not going to lie from 10 to 20. The next one says 40 to 50. Well, no points lie from 40 to 50. The next one says 30 to 40. So that would be from 30 to 40. So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 dots. And then the last one says 20 to 35. So 20 to 35 would be right here. So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So more of the dots lie in this range, 20 to 35%. Number 5, 8 trials are simulated. The results are shown in the table. What is the estimated margin of error? And then it says use standard deviation. So we're going to use the formula plus minus max minus min divided by 6 times 2 because it uses the word standard deviation. So that's going to give us plus or minus, and then you're just going to have to find the biggest number. So 114 is the biggest number. It's going to be your max. 104 is your smallest number. That's going to be your min. So 114 minus 104 is 10 divided by 6. That's going to be, and then don't forget times 2. I'm really bad about forgetting that times 2. So that's times 2. So that's going to give us plus or minus 10 divided by 6 is 3 times 2. That's going to give us a margin of error of plus or minus 6. And how did I miss that? Oh, I didn't divide by 2 correctly. 10 divided by 6 is not 3. Don't know where my brain went on that. 10 divided by 6 is 1.666. It's the reason I like multiple choice answers, because I can hopefully find my mistake. So that's going to give us 1.66666 times 2, 3.33. So plus or minus 3.33. So let's go over that again. Max minus min divided by 6 times 2. 114 minus 104 is 10. Bring over the 6. Don't forget the times 2. 10 divided by 6. I made a mistake there. That is not 3. That's 1.66666. So it's plus or minus 1.66666 times 2. And that gives me 3.33, plus or minus 3.33. So I'm going to choose the second one. Number 6 says the results of a poll show that the percent of people who want a new restaurant is in the interval of 42% to 78%. There are 128,523 people in the city. What is the interval? So that means we want an answer that is an interval. So a min to a max of the number of people. So this interval is percent of people. They want this to be people. So the minimum amount of people and the maximum amount of people. So you're going to take the whole number of people, 128,523, and to find your minimum, you're going to multiply it by the decimal for the minimum percent, which is 42%. So you'll multiply that by 0.42. That is going to give you 53,980 people. So you would put that first. The minimum always goes first. And then find the maximum number of people. You'll take the 128,523 again. You'll multiply it by the maximum percent, which is, as a decimal, is 0.78. And that's going to give you 100,248 people. So 100,248 people. And that's going to match with the first answer. Number 7, a neighborhood organization wants to know what percent of the households want to have a community vegetable garden. The organization plans to survey a random sample of 25 households. What is the best way to randomly, that's probably the most key word here, choose these 25 houses? Should we ask for volunteers? Volunteers is a really big no-no anytime we're collecting data. When we ask for volunteers, we're not strategically, we don't have a plan to randomly select whatever we're trying to get our data on. So we don't ever want volunteers. So that's a keyword that we do not want to answer that one. The second one says randomly assign each household a number. It's a good word right there. Randomly assign each household a number and then use a random generator, which would be a computer, and they would generate 25 numbers. So I think that's going to be the answer, but let's look at the other ones. Ask the households nearest to the proposed site of the vegetable garden. That would not be random data. Okay. Count every fifth house on the longest street. Now, every fifth house might have been a good idea, but they picked one street out of the whole entire neighborhood. So that would not be random enough. And it's going to be the second one. Randomly assign each household a number and then use a random number generator. As much randomness as you can get is going to be the best answer. Number 8 says a sample proportion of 0.43 is found. To determine the margin of error for this statistic, a simulation of 100 trials is run, each with a sample size of 50 and a point estimate of 0.43. The minimum is 0.32. The maximum is 0.48. The margin of error of the population is found using half range. Okay, so that means when we find margin of error, we're going to use the formula plus or minus max minus min divided by 2. So we're not going to do that divided by 6 times 2 because it doesn't say standard deviation in the problem. It says, what is the interval estimate of the true population? Well, first we have to find the margin of error. So we're going to do plus or minus. Max is 0.48. Minus min is 0.032 divided by 2. That's going to be plus or minus 0.16 divided by 2, which is going to be plus or minus 0.08. Now, this is the margin of error. They want 0.08. Let me write that down and then start talking. When I start talking, my brain goes out the window. Okay, they want the interval. So they want the min and the max. So I know that I can add 0.08 to the point estimate to get my max, and I know I can subtract 0.08 from the point estimate to get the min. I've just got to do that part. So I've got my margin of error. That's what I did first. So we got to go back and find the point estimate. So right here in the problem, it says the point estimate is 0.43. So we're going to take, in the second step, we're going to take 0.43 and we're going to add and subtract 0.08. So if we do 0.43 plus 0.08, that's going to give us our max of 0.51. And then if we do 0.43 subtract 0.08, that's going to give us the min of 0.35. So that's why we're going to pick that second one. So 8 was a little bit harder because it had 2 steps. We had to find the margin of error first, and then we had to go back to the problem and take the point estimate and then add the margin of error to get the max, and then subtract the margin of error to get the min. All right, last one, number 9. A football coach wants to see how many laps his players can run in 15 minutes. During a non-mandatory meeting, the coach asked for volunteers on his team to do the experiment. Which sentences explain how randomization is not applied? How the way this coach did it was not random. Select each correct answer. It says the coach is only observing football players. The coach cannot select those that he observes. There is no selection process. He really didn't have a selection process at all. That's what makes this not random. The coach is observing only football players that are attending this meeting. That definitely shows that we're not doing anything that's random to collect data. And then the last one says that football players are volunteering. We know volunteering is a big no-no. That means that nothing is random there. So we're going to check those last 3. All right, guys. Make sure that you go through this. I'll also send you the link to the whiteboard in the video along with a link to this video. All right, let me know if you have any questions. You can send those in emails through email, and I'll be glad to answer them. Y'all have a good day. Bye.